Hi everyone, welcome to this video where we will learn about Amazon Timestream. So before we begin today's video, let me quickly introduce myself. I am Aishwarya Sood. I am working as a lead coach in the AWS domain at Ethnos and I am 4x AWS certified, Amazon authorized instructor, AWS Academy accredited educator, also an AWS Academy graduate. So if you want to connect with me on LinkedIn, here is my profile name, Aishwarya Sood29, and this is a QR code you can scan to quickly view my profile. So without any further delay, let's begin with today's video. What we are going to discuss is what are time series databases and how we can work on time series databases on AWS using Amazon Timestream. What are the key concepts that come within it, the architecture that the Timestream is having, the benefits of it that it delivers to us, and some of the use cases. We'll quickly do a walkthrough of the Timestream, that how do we get started with this, and a few customers that are already using this and how they are benefiting from it. So let's begin understanding the time series databases, because before we understand what is Amazon Timestream, we first have to understand what time series databases are. So maybe you might be aware of this kind of data or not, but time series database is a database that contains time series data for each point in time. Now, what is that time series data? It is a sequence of data points collected over a period of time and at regular intervals, which allows us to track the changes over time. And this kind of data can track the changes over milliseconds, over days, or even over years. And it's generally a collection of values representing how a system or a process or a behavior changes over time. And this kind of data set track the changes to the overall system as inserts, not the updates, which means it is just an append only ingestion system. The new entries are written into the system. You can't modify the already existing value. It is just that whatever new values are coming, they are getting appended to the previous ones. For example, let's say this is a chart for the Bitcoin price. Let's say the opening value of a stock, or you can take the example of a stock or anything. Let's say the opening price of a stock was some rupees, okay, some X rupees, and the closing price of that particular stock was Y rupees. So you know that X rupees is the opening and Y rupees is the closing, but do you know that what happened in between and the whole time when the trading was happening? So that each and every data that was collected at each and every time interval, that is being recorded by a time series database. If you want to notice that each and everything that is happening, because the final price, the closing and the opening, but what happened in between, that each and every point you need to know, that can be done from a time series database, which will record each and every value recorded at a particular time. So another example can be, let's say you have debited 50,000 rupees from your bank account, okay, and after a month, based on various transactions, like small transactions, 50,000 was credited also to your bank account, which means at the starting of the month and at the ending of the month, your bank balance is same. 50,000 you debited in the starting of the month, but due to various transactions, something got credited and some small transactions were there, because of which you got 50,000 as well. So at the end of the month and starting, the balance is same. But if you see the details of it, it is not like that you have not done anything on it. There had been changes happening, some debits, some credits, although the starting and the ending balance is same, but the changes that are there in between at different time intervals, that is what can be recorded with the time series database. So this is how it basically looks like. Some metric is being recorded here at a particular timestamp, okay, for a particular cluster of some servers, you can say. So these are the dimensions of that particular thing, and which particular host is being monitored, and the metric value for the CPU, what is it. So we'll dive a little bit more into it and understand a few more examples for making you understand more. There are a few more examples where this kind of time series databases can be used. For example, in the sales forecasting. So the retail stores can continuously predict the future sales based on the past ones so that they can restock appropriately. So this time series databases have made this thing possible. So what can be done is like the consumer behavior trends and the sales can be cross-referenced, and they can predict the future patterns and make informed decisions about which products to keep in stock and when. Another thing that can be done is to understand the financial records, where using this time series databases, you can accurately predict the financial trends, like how stock price has changed, how it has surged to a high value. Maybe let's say a airline stock got surged, okay, it has got a high value, and how you can get to know that why, what was the reason, how is it trending. Maybe you can cross reference it with the holiday travel, okay, that the holiday season is going on, so people are traveling much. That means the particular company, the particular airline company stock got up. So multiple examples can be there, you can use it for multiple cases. Another examples can include monitoring the software systems, which it might include virtual machines, containers, or applications, or monitoring the physical systems. Then any sort of eventing applications where you are tracking the user or the customer interaction data, and many more. So this way the time series databases will be helpful in many cases. So let me show you something, that how it has been trending over the last some time. Have a look here. So this was a ranking popularity. Let me show you that how a particular database is trending. Have a look the time series databases. This one, how it is trending over time. So from 2015 or so to this 2022, how it is trending, right? And trend of the last 24 months also, if you see, it is quite high, and in the last 12 months also it is quite high. So it is getting a little popular because of the benefits that it is giving to us, and because of a variety of use cases that can fall into it. So for working on a time series database, we have Amazon Timestream on AWS. Let's understand a few important things about it. First of all, Amazon Timestream is a fast, scalable, fully managed, purpose-built time series database that makes it easy for you to store and analyze trillions of time series data points per day. So, fully managed in the sense, your responsibility is reduced. Much of the things will be taken care by the service itself, and moreover, it is serverless, which means it automatically scales up or down to adjust capacity and the performance. Because you don't need to manage the underlying infrastructure, you can focus more on optimizing and building your applications, which is more important. And with Amazon Timestream, you pay only for what you use. It meters separately for the writes, the data that is stored on it, and the data that is scanned by the queries. Also, it has some built-in time series analytical functions which can help you in identifying the trends and patterns in your data in near real time. Also, Timestream can integrate with commonly used services for data collection, visualization, and machine learning. For example, you can send data to Amazon Timestream using AWS IoT Core, Amazon Kinesis, and open source Telegraph, and you can even visualize the time stream data using the QuickSight and Grafana and business intelligence tools with SageMaker for machine learning. Okay, so multiple things can be done. Various data sources can be there, and it can send the data to multiple other sources for your various use cases. Also, it makes it easy to measure how data sets change over time, and you can concurrently view the past, present, and future data sets for reporting that is more accurate and meaningful. Now, what are the key concepts that come in it when we talk about a time series database, or specifically about Amazon Timestream? Let's have a look. Here we have a time series, which is a sequence of one or more data points, which can be, set as a record also. So this is one record, two record, three record. Basically, some record is there. So the set of records is a time series recorded at a time interval. So examples can be the price of a stock over time, the CPU or memory utilization of an EC2 instance over time, or the temperature reading of an IoT sensor over time. So here we are seeing the CPU utilization of some particular instance over time. And then there is record, which is nothing but a single data point in a time series. Then there is a dimension, which describes the metadata of a time series. So it consists of a name and a value. For example, here we have the CPU utilization example. So here the dimension is region, the dimension value is US West, dimension is host, and that is a name, and the dimension value is server 1. And in if we look at the another one, the series 3, here we have another dimensions, region, host, NIC, and the values are given here. Then there is measure name. Okay, so the measure is particularly actual being that is measured by the record. So we have a measure name, which is a CPU in this case, and measure value, which is 65%, 55%, and so on. We are having the value here. So it can be, you can say when we are talking about stock market example, the measure name can be stock price, and the value can be the actual price that was there for a particular timestamp of a particular stock. And the timestamp is basically the time at which that particular event was recorded. So to summarize this whole thing, there's a database first of all, which contains 0 or more tables. Each table contains 0 or more time series. You can see in our table we have 3 series, and each time series consists of a sequence of records over a given time interval at a specified granularity, and each time series can be described using its metadata, or what we call dimensions, its data or measures, and its timestamps. So that's how the terminologies look like in the Amazon Timestream. Now, if we talk about the architecture in the time stream, that how the data gets written and stored, let's have a look. When writing the time series data, the Amazon time stream routes the writes for a table partition to a fault tolerant memory store instance that processes high throughput data writes. So all the data that is written to the time stream initially resides in its write optimized memory store and automatically migrates to the read optimized magnetic store after aging past the memory store retention period. So this we define when we create the tables and the things there. We define that after how much time the data should go from memory store to the magnetic store. So depending on your needs, you can also have the time stream delete your older data automatically or may retain it indefinitely. The memory store in turn achieves a durability in a separate storage system that replicates the data across 3 availability zones. Okay, and in near real time, other in-memory storage nodes sync to the data in order to serve the queries. And Timestream also supports writing directly into the magnetic store. This is also another option that from here you are writing directly into magnetic store for applications that basically generate the lower throughput late arrival data. So it is used in that case. What basically is late arrival data is, like as the name also suggests, it is a data with a timestamp earlier than the current time. So let's say if it is 2 p.m. now, maybe the data was recorded at 1:30 p.m. or something like that. So similar to the high throughput writes in the memory store, the data written into the magnetic store is also replicated across 3 availability zones. And all the time stream queries are written in SQL grammar with extensions for time specific support, which means the time series specific data types and the functions are supported here. That's how the architecture looks like. Now what we'll do is we'll go to the AWS console and we will see that how we can get started with Amazon Timestream. So let's go to the AWS console and see how does it look like. What we'll do is we'll search for Amazon Timestream. And make sure to note that Amazon Timestream, as of now, it is not available in all the regions. I have chosen North Virginia. Of course, it's available in North Virginia. but you can check what all regions it is available in as of now, and accordingly you can plan choosing the regions for your other resources as well. So what we'll do is we'll create a database by clicking on create database, and here we have got two options. We can create a standard database, which means we can define a new database and choose the custom configurations. But if we want to go ahead with the sample database, which means we are just getting started and we want to explore that how the things look like, then we can go ahead with this one as well. So for this demo, I will go ahead with the sample database itself. I'll give it a name as sample, and here I can choose what tables I want in my sample database. I'll choose both of them, IoT and DevOps. Okay, you can choose one or you can choose two depending on you. So DevOps table contains the easy to instance metrics such as CPU, network and memory utilization to help monitor the application performance and availability. That sort of data it is including. And this IoT is containing the IoT sensor data from one or more truck fleets to streamline the fleet management and to identify the cost optimization opportunities such as reduction in the fuel consumption. So you must have got the idea that what kind of data is there in both of these tables. Now we can go ahead. So you can go for multi-measure records or you can go for single measure records. Multi-measure records in the sense which stores multiple measures in a single table row. Okay, like how we saw in the example key concepts table that I was showing you. And there can be single measure records where there is just a single measure per table row. So we can go ahead with this one as of now, single measure records, and click on create database. So our database is created, sample, and within this sample, we have got two tables, DevOps and IoT. Okay. And what we'll do now is we'll click on the sample database and you can check the summary of it. The name is given and the KMS key is given. So why is it so? Because with when we create a database, we get a key created here. Okay, so we get a key created here. Have a look here. So we can't disable the encryption for Amazon Timestream. The data will be encrypted as I told you. Okay, so this is a default key that protects any Timestream data when the no other key is defined. So you can define your own key also. You can use the default key also. Completely up to you. And we'll not modify it. Let's go back. And there in the monitoring tab, you can monitor your database metrics at this place. Okay, so you will get all the information once everything is active. Then what tables you have, these two tables you are having, let me open any of them. Let's say open IoT. So here let me show you all the settings. Database as sample, table name is IoT. Memory store retention, it is by default 24 hours. Okay, and you can define minimum 1 hour and maximum of 12 months. After that, it has to go to the magnetic store. Okay, I was telling right in the architecture, so it has to go. So you can define after 1 hour also it can go. Okay, or maybe after 1 year also it can go, or you can define it in the days, weeks, or months also. Then magnetic store retention, that how long it should be there in the magnetic store. So you can define it as less as 1 day and maximum as 200 years, or you can define it in the weeks, or you can define it in the months or years as well. Let it be days, which is 1825 as of now. So you can specify whatever you want. And enable magnetic store writes, if you want to enable, then it will be writing directly to the magnetic store. Okay, so I told you right, there's an option that it can even directly write to the magnetic store instead of writing to the memory store and then to it. So if you enable it, that will happen. Otherwise, by default, this is disabled. Let's click on save. Anyway, I didn't change anything here, so it is now saved. So we have got a quick idea about like the databases and their details and the tables and their details. We don't have much here. Okay, just a few more things. Now we will talk about query editor, and here we go. We have a query editor where we can check out the recent queries that was run, the saved queries if you have any, like you wrote a query and you saved it for using it quickly the next time you need it, you can save it. Then there are sample queries for both of these databases, IoT and DevOps. For example, let's say in the DevOps, what query we have, identify the EC2 hosts with the CPU utilization that is higher by 10% or more compared to the average CPU utilization of the entire fleet for the past 2 hours. So if you want this information, all that you have to do is select this query, okay, and run it. You will get the output over here. Have a look. So this is showing the average CPU utilization for the host which has been greater by 10% or more than the fleet average CPU utilization. Okay, the overall fleet CPU utilization, if something has been greater for those hosts, it is showing. So the region dimension, it is one dimension. This is a dimension value. AZ is another dimension, and this is another value. Host name is another dimension, and this is another value. This is a measure, and this is a measure value. Okay, so this is how it is looking like. You can click on output. Okay, what number of rows were returned, and the statement, what it was all about. Then the table details, we don't have any as of now because we have not selected, and this is our output. You can check out another queries. Let's say I want this one, or let me check which one should we take. Load efficiency, you can check. Okay, so what else we have? Most recent fuel reading. Okay, let's check this one. So it is going to get us the most recent fuel reading of each truck in the fleet in the past 24 hours. Let's go, and the query we have got here. Let's run it. So we will be getting the results. Here you go. Okay, so what we have got here, truck ID. So the truck IDs are given here, the dimension and their values, fleet which they belong to, and what is their make, what is their model, and the timestamp at which it was recorded, and the last reported fuel reading, which is a measure name and the measure value. So what we have got, 40 rows have been returned here, and what is it about? You can read here in the query editor. Okay, that's how you can work with it. This was just a sample database and the sample tables that we used. You can, of course, create your own table and add your data, run the queries as and when, whatever you want to do. Now let's go back to the time stream and see what is left in this. We have resources. We discussed about databases, tables also, and management tools. We saw the query editor. I showed you the monitoring also. Now what is the scheduled queries? We can create a scheduled query. So what basically it is like, you can define some queries which will be running automatically periodically by Amazon Timestream. So what can be the use case for this is like, let's say you have a normal database for the stock prices, which is recording all the stock prices at the regular time intervals. And on that database or that table, let's say this was our database and this was our table where the stock prices was getting recorded. Just assume that. And what we want is that, because the basic table will be returning a lot of values, right? But what you are doing, you are creating a scheduled query which will aggregate some of the particular data, okay, as per your need at some particular time, and it will store the result, that meaningful result, just one result, in some separate table. Okay, so you have a base table which is this one. On that you are performing a scheduled query after some particular time, okay, so that it aggregates all of that data and stores the final meaningful result in a separate table, so that then you can point that database to a dashboard. Okay, so that in the dashboard you are not going to get any unnecessary data. What you are getting is just the important data that you have got as a aggregated values, not the whole data that you got from the base table. So in those cases, scheduled queries can be used, which will be running automatically and periodically at the timings you specify. So you can give it a name. Anyway, I'll not be creating the sample. I'll not be creating the scheduled query. I'll just show you that how it looks like. So you select a database, a table, and the query name you give, and then you enter the query here, which should run after specific periods of time, and then you specify the destination table schema where the results are going to be stored. Okay, and then you specify its time and all that when it should run, and finally it will be created. So that's how it works. So now what we know is we have got to know about all of these resources that are there in Timestream. I hope you have got a good idea about how to work with all of these resources and the management tools that we have. Now we will go back to the presentation and we'll discuss a few more things about it that are necessary. So let's have a look at a few use cases that it has. So this is DevOps data. This Amazon Prime Stream will be ideal for the DevOps solutions that monitors the health and usage metrics and analyze the data in real time to improve the performance and availability. Okay, so what's happening? The source data is there, and through the data collection agents, it is coming into the time stream. And once the data is there in the time stream, you can visualize it using QuickSight. You can use it with a SageMaker, you can use it with Grafana, the JDBC clients. Okay, you can visualize, analyze, and process this data using your favorite tools, what suits your use case. And in this, what can be the example? So, like how we were seeing other examples as well, the CPU utilization. So, you can collect and analyze those kinds of operational metrics and monitor the health and optimize the instance usage based on that. Another thing can be this one, the clickstream data. So here what's happening is with the clickstream data, you can use the time stream to store and process the incoming and outgoing traffic for your applications. And time stream will provide the aggregate functions to analyze this data and get the insights such as path to purchase and shopping cart abandonment rate. Okay, so these can be done. More examples if you want. It can be used for monitoring the metrics which can improve the performance and efficiency of your applications, or it can be used for storage and analysis of the industrial telemetry to streamline the equipment management and the maintenance, or it can be used to track the user interaction with an application over time, or it can be used for storage and analysis of the IoT sensor data. So these are some of the examples and the use cases. You can use it for many more beyond this as well. What are the benefits of using time stream? So by now you would have a good idea about how the time stream is beneficial, but let's discuss a few benefits here. So with Amazon time stream, there are no servers to manage since it is serverless, and there is no capacity to provision. As the needs of your application change, time stream will automatically adjust the capacity to accommodate the load. And there is simplified data access with timestream. You no longer need to use the disparate tools to access recent and historical data. There is a purpose built query engine transparently accesses and combines the data across storage tiers without you having to specify the data location, right? And which simplifies our data access. Apart from that, there's a good durability. Amazon Timestream ensures the durability of your data by automatically replicating your memory and magnetic store data across different availability zones within a single AWS region. And all of your data is written to the disk before acknowledging your write request as complete. Also, it is always encrypted as I showed you on the console. Whether the data is at rest or is in transit, it will be always encrypted. You can't disable the encryption. Also, Amazon Timestream ensures high availability of your write and read requests by automatically replicating the data and allocating the resources across at least 3 different availability zones within a single region. Also, it is purpose built for time series specifically. You can quickly analyze the time series data using SQL with built-in time series functions or for smoothing, approximation, and interpolation. So these are some of the benefits that are there with the Amazon time stream. Let's look at the another thing. So the time stream alone also can be used. Okay, you can use it for your various use cases, and it can be used to even enhance and even bigger cases when we use it with other services. We can use it with AWS Lambda, like we can create a Lambda function that interact with Timestream. For example, we can create a Lambda function that runs at regular intervals to execute a query on Timestream and send an SNS notification based on the query results and which is satisfying one or more criteria. Or we can use it with Amazon QuickSight to analyze and publish the data dashboards that contain our Amazon Timestream data. So we have some data in Timestream, okay, and now we want to see a good, nice dashboard out of it so that we can, visualize it and analyze the data in a better way. We can use QuickSight with that, and we can use it with SageMaker. So we can use SageMaker notebooks to integrate machine learning models with the Amazon Timestream. Apart from that, we can also visualize the time series data and create alerts using Grafana. Okay, so this way you can have multiple purposes solved with the time stream. Let's have a quick look at the customers who are already using Timestream and how it has been beneficial for them. Let's have a look. So there is the organization Abius who has said that with Timestream, we are seeing the value of a database purpose built for the time series data. So previously they used a custom database solution for this purpose in their application cluster, managing the time series data with the block storage, and the Timestream's serverless architecture has allowed them to scale without worrying about the database solution while reducing the overhead cost. So you can see that, because of course when you don't have to manage these many things, it becomes easy. You can focus more on your products, your application, and the customers and the data. And Autodesk also has used Timestream. Okay, so what has Timestream done to them? They can see that Timestream has a potential to help deliver new workflows by providing a cloud hosted, scalable time series database, and they anticipate that this will improve the product performance and reduce the waste in manufacturing. Of course, because now you don't need to build this kind of solutions on your on premises, which is extra added effort which you do not need to do. So another differentiator that excites them is the promise that this value will come without adding a data management burden for the customers or nor the Autodesk, of course, because it is like fully managed and also is serverless. So you can read more about the customer stories here on the customers page. Just look for the time stream page and check out the customers. Yeah, and you can read about their stories. So that's all about Amazon Timestream for today. I hope you have got the good idea about how you can get started with Timestream and how it can be helpful for your use cases. Now we will meet in the next video. Thank you.